Assalamualaikum and good day class. So today we're going to learn about chapter 3.3 Hardenability. Here are the learning outcomes. At the end of the day, you should be able to differentiate the concept of hardness and hardenability and develop the hardenability or Jominy End Quench Test procedures and process. What is actually hardenability? It is actually a measurement of the depth in which a metal or an alloy are being hardened due to formation of martensite as a result of a heat treatment. To produce the martensite, the steel are being heated above the eutectoid temperature, which is above 700 to 27 degrees Celsius, and rapidly cooled to form a martensite. Generally, the cooling rate will determine the formation of martensite, and it is largely depend on what kind of medium that you use for the quenching. For example, we can use water, oil, or even air cooling. Water provides faster cooling compared to oil and air. In general, the faster the steel cools, the harder it will be. What kind of test that we use to measure the hardenability? The test is called as the Jominy End Quench Test. So as you can see from the picture, water are given at the end of the heat-treated steel, which is actually the hot sample. So this part will cool faster compared to other area. And here are the apparatus for Jominy End Quench Test. The hardenability of steel can be determined through Jominy test. It is a test that will be used by a standard practitioner to measure the hardenability of steel by first doing a heat treatment on the steel and then quench it in the water, and it will show different effect of cooling rate on the steel hardness. The process starts by heating the sample above the eutectoid temperature to produce austenite microstructures. After ensuring that all structures has transformed to austenite, it will be then taken out from the furnace and fixed in a vertical position before quenching it with a water jet. Only the end part or the flat part of the bar will be quenched with water jet, and this will produce different cooling rate along the steel bars. After quenching, the flat portion will then be ground up to 0.38 mm deep, and then hardness measurement will be made along the length of the test piece from the quench end. To measure the hardenability of steel, we need to have a different parameter, which is it will largely depending on the Jominy distance. So the Jominy distance is actually the distance from the quench end of the Jominy bar, which is related to the cooling rate. Let us take a look at the videos.
Jet water, and that will cool the bottom. It'll be more interesting when we put down on there.
So here are the Jominy End Quench apparatus. As you can see, below the test.
I just want to record this for future generations, yeah?
Water jet. So we take out our samples that already turned into austenite plate or austenite microstructures. As you can see, it is in red bright colors, and we put it in vertical position and we let the water jet
So if you look, you'll see it cooling from the bottom. And you've got
turn, okay?
going from the red proceeding up towards the top. I'll give you an idea of how the temperature varies.
From bright red to grey color, which actually shows that the hardenability occurs
Oh yeah.
as the sample are being quenched. Okay. So what do we get? Okay, after we conduct the Jominy End Quench Test is actually the hardenability curve. It is a curve that shows the effect of cooling rate on the hardness of quenched steel. Let us take a look at this graph. Okay, this part where the hardness is the highest is actually where the distance between the water jet and the end of the sample are very near. This is the part where it first hit the water, so the hardness is much more higher, the highest amongst all, and it will slowly decrease as the Jominy distance, okay, become increase. Okay, so this part where they have the highest amount of martensite, and this part has the less amount of martensite, so it became much more softer. Therefore, it can be concluded that the distance from the quench end is actually the equivalent measure of the cooling rate, and it can be used to determine the hardenability of the steel. Okay. Let us take a look at the relationship between the hardenability curve and also the TTT diagram curve. Okay. Look at the graph. We can see that this is the end quench of the sample. Okay, where the hardness is the highest. Okay, as you can see here, the temperature increase. Okay, when it first came out from the sample, and then it will drop until it form the martensite. So this part is actually the part before it reach the water jet, and then it will drops after it reach the water jet. So the cooling rate will decrease with the distance from the quench end, and greater carbon diffusion actually resulted in more formation of perlite and bainite, which resulted in lower hardness. Let us take a look at another example of end quench hardenability test. Okay, so here are the results of the hardenability curve for 5 different steel. Okay, as you can see, okay, from this graph, we can see that there are only small variation in the composition that can change the shape of this curve. It is because this steel 4340 has higher amount of carbon, so the effect on the curve are less compared to steel with less amount of carbon and alloy. Okay. So we came to the difference between hardness and hardenability. So hardness is actually the resistance of the material to any penetration or plastic deformation or scratching on the surface of the sample, while hardenability is actually the ability of an alloy to be hardened due to formation of martensite as a result of heat treatment. So conducting hardness, we do not need to conduct any heat treatment, but if we want to conduct hardenability test, we must conduct the heat treatment before we conduct the test. And the hardness test is actually measuring the resistance of material to the penetration by sharp object. So we apply sharp object on top of the surface and we get the amount of hardness. But hardenability, conducting heat treatment to the sample, and it will show the effect of cooling rate to the steel hardness, okay, which actually depending on the quenching medium and also composition of the sample. Okay, as an example, okay, as you can see here, we have two examples of material, which is kitchen tile and eraser, and of course the kitchen tile, okay, have more hardness. It's much more harder than the eraser. And here are the image of the hardenability test specimen and how it is being conducted. Okay, let us take a look at the exercise. Okay, hardenability can be defined as an ability of an alloy to be hardened by the formation of martensite. Explain 3 factors that can influence the hardenability of steel. So generally, we all know about the quenching medium before, okay, and then the cooling rate, okay, and the other two is actually the amount of carbon and element. The higher the amount of carbon, the higher would be the hardenability. And of course, point number 2, the cooling medium. Okay, highest hardenability will be obtained by water, followed by oil, and then lastly by air. And of course, the specimen shape will also determine the hardenability of the steel. The higher the ratio of surface area to the mass, the higher the hardenability of the sample. Okay, figure below. Okay, we move on to question number B. Figure below show a sample that have been proceeded to Jominy End Quench Test. Identify the microstructure at each point A, B, C, and D. So this is the point where it first hit the water jet and along the way it become much more distant lah. Okay. So of course, okay, the one that already touched the water is rapidly transforming into martensite, and then point B, martensite plus perlite. Point C, okay, is actually fine perlite, and point D is perlite. That is all, class, for chapter 3.3, Hardenability of Steel. Thank you so much for your attention.